Hi guys, Mrs. Gates here. I just wanted to run through a quick review of how to set up and solve conservation of momentum problems. The key with solving any physics problem is to clearly visualize the problem before you start using any numbers. Often a diagram is incredibly helpful. In this situation, we have a collision between two different carts, and we can see here what is happening before the collision and what is happening after the collision. When we look at this, we notice that before the collision, both cars are moving. After the collision, both cars are probably moving, though we don't know the velocity for this second car. This is what we are going to be solving for as we are looking to solve this problem. Anytime you see a problem about a collision or explosion, the thing that should come to mind first is that this will be dealing with the conservation of momentum. The conservation of momentum means that if we add up the momentum of all of our objects before the collision, that will be equal to the sum of the momentum of all of the objects after the collision. So before the collision, we have two objects that are moving. So we will have two terms on the left-hand side. Remember, momentum is equal to mass times velocity. So as we look over here, our 1 kilogram car has a mass of 1 and a velocity of +5. We add that to the momentum of our other car, which has a mass of 3 and a velocity of -5. Okay, and that takes care of our momentum before the collision. After the collision, we have two cars still moving. The first car has a mass of 1 and a velocity now of -5. And remember, momentum and velocity are both vectors, so keeping the positives and negatives straight is important. The other car, our 3 kilogram car, has a velocity that we don't know yet. We think it's probably moving to the left, but we'll leave it as just v, and the sign, the positive or negative on our answer, will tell us whether or not that's moving to the left or to the right. Once we have this set up, then it's a matter of solving this equation for velocity. So if we look back over here, 1 times 5 is 5. 3 times -5 is -15. And over here, 1 times -5 is -5 plus 3v. All right, solving one step farther, 5 minus 15 gives us -10. Minus 5 plus 3v. We add 5 to both sides. -10 plus 5 is going to give us -5 equals 3v. And then finally, I solve for v, and I find that v is going to be equal to -5/3 meters per second. And this is my final velocity. Notice that it's a negative velocity, which means that our car is going to be moving to the left, just as it was indicated up here, right? And I can write v equals -5/3 meters per second as my final answer.